Hi viewers, today we are going to discuss about basics of power system. The power system is a necessary thing for now today's life. Without power, we can't do anything. So we can discuss in detail with basics of power system. This power system has consist of power generation, power transmission, and power distribution and power consumption. So integration of these things is called as a power system. Okay, power system is a integration of power generation, power transmission, power distribution, and power consumption. What for we are generating power to consume. Okay, so thing is to satisfy the end consumer's requirement, we are going to generate the power. So next, if you want to generate the power for various using various power plants, we need energy sources. Using that energy sources only, we can able to generate the power. Okay, so power plant needs some energy sources. Based upon the energy sources what we are using, depending upon that, the power plant also will be classified. So, in this energy sources, as majorly classified into two things is one is a conventional energy source, another one is a non-conventional energy sources. If it's a conventional energy sources, if we are using the conventional energy sources, the, we can't able to utilize once again. Once we used it to generate the power, the end product will be a ash or some other things only. We can't able to reuse that one. That kind of energy sources is called as a conventional energy sources. The examples of conventional energy sources is coal, uranium is coming under the category of solids. If it's a liquid, the petroleum we can use as one of the conventional energy source. Then if it's a gas fuels or natural gas, they are using that. Okay, these things are as a conventional energy sources. The main thing about this conventional energy sources, if we are using these energy sources to generate the power, after that once again we can able to the same energy source. It means if I am using 100 kg coal or 1 kilogram uranium to generate the thermal power plant as an energy source. Okay, so after generating the power, this coal will be ash, the uranium will be ash. Okay, it will be extracted as a smoke via chimney. That's the meaning of we can't able to use it. If we want to generate more power, we need a again we have to use it the same solid energy sources, liquid or gas fuels. We can be use it depending upon the power plant what we are using. If it's a conventional power plant, majorly we can use the solid and liquid gas fuels to generate the power. If we see non-conventional power plants, we can use the non-conventional energy sources. The name, if it's a conventional power plant or non-conventional power plant, the name which comes based upon the energy sources what we are using. In case of non-conventional energy sources, okay, we have an example, tidal power and wind power, geothermal, solar, okay, and wave power and biomass and biofuel. These are the examples of non-conventional energy sources. The majorly we are using uh, wind and solar energy to generate the power using the non-conventional power plants. Understand? So this energy sources is very very important because without energy sources we can't able to generate the power. Okay, then power plants. So previously, what we discussed about the power plant. The power plant has a major classification. is a conventional power plant and non-conventional power plant. If it's a conventional power plant, why the name is came? Because we are using the conventional energy sources in these power plants. That's why we can say as a conventional power plant. If it's a non-conventional power plant, if we are using the non-conventional energy sources to generate the power in this power plant, the type of power plant is called as a non-conventional power plant. So what's the definition? Just the definition of power plant. The machine or assemblage of equipment that produces and delivers a flow of mechanical work and electrical energy is a power plant. Gas using the mechanical energy is converted into electrical energy. Okay, to uh, to get a kinetic energy or to mechanical energy, we are using various energy sources in the power plants. Understand? Then, if the case of conventional power plants, we know if it's a conventional power plant, we are using the conventional energy sources. The first thing is a hydropower plant. So, in this hydropower plant, the major energy source is a water. Okay, we have to construct the dam and we have to store the water in the dam. From the dam, through the reservoir, that the water will be stored in the dam. So from the dam, the water will high pressurized water will flow through the penstock and it will hit the turbine, the water turbine. Okay, then the turbine will rotate. The turbine which is coupled with the armature of the generator. So because of the high pressurized water is heating the turbine will start to rotate. Because of that, the armature also rotate. That will cut the field which will be generated by the magnets. So the power will be generated as per the Faraday's law of electromagnetic induction principle. Then next one is a thermal power plant. Same thing. So here we used is a main source and the energy is a water we are using. So to construct we need have to construct the power plant. And also the thing is to construct a hydropower plant is difficult because we have to choose the place where more rainfall is throughout the year is there. So the possibility we have to check it. So we have to construct the dam. We need a more area is requirement is more, and also it will take a lot of time to construct this dam. After that only we can design a power plant. Okay, it's called as a hydropower plant. If it's a thermal power plant, in this thermal power plant we are using coal as a energy source to generate the power. Okay, so using the coal here we are using to the heating of the water. We have a water uh, we are having with that there. So if we are due to the coal, we are the heating of the water. If you are heating of the water, okay, high pressurized steam will coming out from that. That high pressurized steam will hit the turbine. Okay, the turbine will be rotate because of the high pressure produced by the steam. All of you know the steam pressure. Okay, so because of that, the turbine is rotate, and also the turbine is coupled with the armature. The armature also will be rotate, and then that will be cut the flux produced by the magnetic poles. Then the EMF will be induced. The power is generated. Okay, so we have important parts in this. In all of you know about the generators already. You know the main parts which are all required for the generator is armature, is rotating part, and stationary part. Okay, the rotating part is called as a armature. That should be rotate. To rotate that armature, we need mechanical energy. That mechanical energy will be generated or produced by using the energy sources depending upon the power plant. Okay, if we are taking of nuclear power plant, the uranium is a energy sources. So the same principle we are using here also, thermal and nuclear. So if it's a nuclear power plant, if we are using uh, the uranium as a energy source, so that will be using as a used to flame up, then the water will be produced high pressurized steam. Again the steam turbine will be rotate because of the high pressurized steam produced by the nuclear power plant. Okay. Then that coupled armature will be rotate, the power will be generated. Okay, now the only thing is the thermal and nuclear. So here that energy sources what we are using, that is differ from various power plants. Okay. So uh, if you are in case of 110 coal is required for a thermal power plant, that kind of kinetic energy what will be produced by that maybe 100 k, I mean 1000 kg, that will be equal to the 1 kg of nuclear, I mean uranium. So it's having a major difference between the utilization of a coal and nuclear. If you are using 100 kg, it will be equal to, for example, if you say 1 kg of nuclear, the same kinetic energy will be produced. That's why that, but the safety wise, it having some problems. But engineers can we design is properly on the power plants, so we never worry about that safety. That's why we have having an engineers are here to design a power plants perfectly. Then similarly, if you are using a gas or diesel, that also used to rotate the turbine. Okay, then the power will be generated. So these are the contents and also the types of various power plants depending upon the using of energy sources. I mean conventional energy sources. That's why we are telling as a conventional power plants. Okay, the conventional power plants, the conventional energy sources. Okay, the conventional energy sources we are getting from the nature. Fine. Then types of non-conventional power plants. Say solar power plant, wind power plant, geothermal, tidal, biomass and biofuel power plants. Then why we are going for non-conventional power plant from the, why we are using going for the non-conventional power plant from the conventional power plant? Because all of you know about that the conventional power plant need energy sources, the conventional energy sources, that's say, coal, uranium and diesel, gas, everything from earth we are getting. We know the theory how the coal is generating or creating by the by nature. Okay, so long ago, because of natural disorders, all forests are destroyed. Then that will be after a million of years, that will be converted as a coal and petrol and diesel. Okay, so if you are taking continuously from the earth, the coal or petroleum or diesel, whatever maybe it is, once if you are continuously taking, one day it will be empty. One day it will be, the conventional energy sources will be empty. Then what will we do to generate the power? That's the thing. That's why we are moving for non-conventional energy sources. If you are using the energy source, non-conventional energy sources, that type of power plants is called as a non-conventional power plants. Okay. So why the necessary thing is essential thing of non-conventional energy sources? But due to the increasing of the population and also the industrial industry also increase, population also increase, industry also increase, and vehicles what we are using that also will be increase. So once the demand is getting increased due to the population and industrial development, so to meet the demand, we need to generate the more power. We need to generate, we are in a situation to meet the demand of the power requirement by the consumers. Okay, so if you are depending only the conventional power plants, okay, so we can't able to meet out, because day to day the energy requirement, the demand getting increased continuously, so we can't able to meet out. That's why we are going for that this alternate energy sources, that is called non-conventional power plant. Then what is the difference between the conventional energy sources what we used for conventional power plant, then then non-conventional energy sources what we are using for non-conventional power plants? If we are using the solar energy, okay, if you, for example, you can take as a solar, the solar energy is giving from the sun. Yes, continuously it will producing the solar energy we are getting from the sun. Okay, so using this solar energy we can we have solar panels. We can design a solar panels. The array of solar panels we are having that having a chemical coating. That chemical energy will be converted into electrical energy. Okay, due to the heat given by the sun. Okay, sun is naturally available resource. Once if you are today I used continuously I am using sunlight, tomorrow it will be empty, it will never get empty. And also we can't I no need to purchase the raw material which is required to generate the power plant. Okay, we are not paying any amount to the sun or to the wind to purchase the energy sources. But in case of conventional energy power plants, the conventional energy sources, if you need more amount of tons and tons of coals, even though if we are having the coal mines, okay, but we are importing from foreign countries. Okay, then we are transporting from if you suppose coal mine is from one place, we have to transport that raw material to where the power plant is located. Okay, the transportation charges will be there, but the transportation charge and production charge is not there if you are using in the non-conventional energy sources. It is a major the cost wise is very less comparatively conventional power plants, because we have to construct the power plant and we need the energy sources. And the energy sources we have to purchase it from the foreign. If it's a uranium, if it's not available with us, even though if we are not insufficiency happening because of demand, we are purchasing from foreign countries. Even though if we are coal mines we are having, but we are purchasing from other countries. So the transportation charge, purchasing charge of the conventional energy sources is very high. Okay, if you compare with non-conventional energy sources, we are not paying any money to the naturally available resources. But coal also naturally available resource, uranium also naturally available resource, petroleum also naturally available resource. But we are paying the money. Okay, we are purchasing it, then we are utilizing to generate the power. So in that cost wise is very less. And also one important thing we have to be keep in mind, if we are using the conventional energy sources except water. Okay, if you are using a uranium or coal or petroleum. Okay, when the diesel generator. Okay, so the end result will be a ash of the coal, and also through the chimney it will be the smoke will be coming out. Okay, the where we will be dispose that ash, we are disposing to the sea. Okay, so sea is polluted. Nowadays they are using for the ashes to in the process of producing cement. Okay, but the pollution is increasing if we are using the conventional energy sources. Once we know the green energy we needed, if we continuously if we are polluting that nature, one day we can't able to breathe, we are not able to breathe good oxygen, so we can't able to live in this world. So to avoid that kind of pollutions, the water pollution, air pollution, land pollution, various pollutions will be occurred because of using of conventional energy sources. So we need alternate. That alternate sources is called as a non-conventional energy sources. If, if we are using the non-conventional energy sources to generate the power, that type of power plants is called as a non-conventional power plants. Solar, wind, geothermal, tidal, biomass, and biofuels. These are the types of non-conventional power plants. Okay, so we are using the solar energy. Here we are using the wind energy. So high wind, if we are produced by the nature, so automatically in the blades will be, all of you seen that in your areas the wind will be rotate. So automatically once it is rotate, okay, the thing is once here the wind, but difference between solar and wind, if you are using the solar panel, the chemical energy which is converted into electrical energy, the chemical energy, the reaction will be converted into electrical energy due to the heat will be produced by the sunlight. Okay, so we can directly getting the DC output from the solar panel. If it's a wind power plant, due to the high wind, the wind blades are rotating. Once it's rotating, it having a gear arrangement, the speed will be getting increased. Okay, so automatically the shaft which is coupled with that generator through these windmills, that also will be rotate. Then the armature also will be rotate. Then alternating current will be coming out through the wind power plant. Okay, if you are seeing a photo conventional power plants, in this conventional power plant also we are getting the AC output. Fine. Then geothermal, tidal, and biomass, biofuel having a is some of the examples of non-conventional power plants. Okay. So already we discussed we have a power power generation. Okay, that we see. Then next one is a power transmission. So once we generate the power from the power plant, we have to transmit to the we have to, if we are generating the, why we are generating the power? To meet the demand of the consumer. Okay, to meet the demand of the consumer, we are generating the power. So the power plant is located from some other place, so that power what we generated, that should be transmit to the end consumer. Okay, for that we are using the transmission system and distribution system up to the end of the tail end consumers. Okay, so this transmission system has classified a primary transmission system and secondary transmission system. So once if you are think about the power plants, we have to be designed the 11 kV as a output of one power plant. For example, if we taking as a Ennur power plant, Ennur Neyveli power plant, or any nuclear Kalpakkam power plant, wherever maybe it is, but wherever we are generating the power, but consumers are throughout the India. Okay, we are transmitting continue throughout the nation. We are transmitting the power wherever we are generating, wherever more generation is there. So we can through the grid we can transmit depending upon the requirement of the different states. Okay, so for that we are using the transmission system. So if I am generating 11 kV as a output of uh, one power plant. Okay, if maybe a thermal power plant or a conventional power plant or non-conventional power plant, that 11 kV, if I have to transmit, for example, 1000 kilometer, this 11 kV has to be traveled. Okay, through the transmission lines. So it's very difficult to transmit. It's not a difficult, because if you are transmitting this 11 kV from the power plant, while we are receiving, due to the various losses, we can't able to receive the same 11 kV to the tail end. Okay, automatically. And while if for example, if you can able to run continuously 10 kilometer speed continuously 10 hours 20 hours, it's not possible. At one extent, automatically our speed will be reduced. Like that, due to the losses, the power what we are transmitting, that will be reduced. Okay, so to avoid that, what we are doing, using the transformers, if we are stepping up the power what we generated in as 11 kV, okay, to the 230 kV. The 230 kV is running through the transmission system, through the transmission wires, so through overhead lines. Okay, then it will reach the substation. That is called as a primary transmission system. If it's a secondary transmission system, that to 30 kV may be depending upon the requirement. If it will be stepping down into 33 kV and 66 kV, okay, and 11 kV, based upon that, that will be again stepping down. Then we are transmitting. That is called as a secondary transmission system, depending upon to meet the consumer. Okay, so primary transmission and secondary transmission system. Next thing is the, see, this is a structure what we are using, that towers is a transmission lines. Okay, these transmission lines, and all of you seen this type of towers, the transmission towers, while seeing in that outside of while traveling bus or whatever maybe it is. Okay, so from where we are getting the power? Through these wires. Okay, from the generating station, from the generating station. and generating station is far from the receiving end. Okay, so from the generating station through this type of towers, we have to construct the towers like kilometer, various kilometers it has to be traveled, no? So we have to construct the towers. Then the tower construction is there. So you have to erect, and the design is very very important. Then the wires using that, the power is transmitting from the power plant, I mean from the generating station. Okay, then this is transmitted. Next. Okay, distribution system. Once we transmitted, okay, once we transmitted from generating station to generating station, we are transmitting the power. That power has reached the substation. The power has reached the substation. From the substation, they are distributing the power to the, depending upon the consumer's requirement. That is most important. The consumers are bulk consumers, commercial consumers, and domestic consumers. We can classify it like that. Okay, if you are primary distribution system, in the case is if you are directly giving the power to the bulk consumers, like industry peoples. Okay, if you are directly giving the 11 kV to the industries, that type of distribution is called as a primary distribution. Okay, we are using the different feeders for primary and distribution and the secondary distribution system. If we say the secondary distribution system, the commercial and domestic consumers, for our houses, if we are getting the power, no, that kind of distribution system is called as a secondary distribution system. Once if you are giving the directly the requirement what is given by the industry, from the substation, from the electricity board having a substation, from the substation, from generating station to power is transmitted through the transmission lines, then it will be reached the substation. From the substation, they are dividing, it means they are distributing to the, depending upon the consumer's requirement. Okay, that consumers is maybe classified is a bulk consumers, and commercial consumers and domestic consumers. So if you are giving the, if you are distributing the supply to the bulk consumer, that is called as a primary. If you are distributing the power through the to the domestic consumers, that kind of transmission is called as a secondary distribution system. So we have power generation using the power plants, then power is transmitted through the transmission lines. Okay, then that will be reaching the substation. From the substation, we are distributing the power depending upon the need of the consumers. Yeah, okay, the consumers having the classifications. Fine. This is a structure of power distribution system. So this is a substation. Okay, so I told the bulk consumers, the industry people, they can need it. So the domestic consumers here, so industry also directly they can get a power. Then using these transformers we are transmitting. Okay, uh, distribution transformers, we are using the distribution transformers, because already I told we are generating 11 kV power in the power plants, that will be stepping up through the step up transformers, that after that that will be transmitted through the transmission system, then that will be reach the substation. From the substation, that will be distribute using the distribution system, depending upon the consumers requirement, depending upon the consumer's requirement. Okay, so I told we have 11 kV power, 66 kV and 33 kV, we have different feeders we are having. So what is the requirement of the domestic consumers is 440 volt. Okay, so 415 to 440 volt we have a we need a domestic consumers. Then what we have to do, we have to construct the transformers. That type of transformers is called as a distribution transformers. Using the distribution transformers, that 11 kV voltage will be stepping down into 440 volt, the 415 to 440 volt, that will be distributed to the domestic consumers. We can see that type of distribution transformers, your streets. The street side transformers is called as a distribution transformers. Each transformers will cover the particular area that will meet the demand of the domestic consumers requirement. Fine. Then the end load system. Okay, so we told our power plants which is used to generate the power, then we are transmitting the power through the transmission system. Then the transmission system, the power has received to the substation. From the substation, we are distributing through the distribution transformers. Depending upon the consumer's requirement, it has classified primary distribution and secondary distribution. Fine. Then for what purpose we are distributing to the for consumers load? I told no, the industrial consumers and commercial consumer and residential consumer. Okay, so up to the load end we have to satisfy. No, I mean, I told already the demand getting increased, then the meat also getting in. We have to meet the demand. We have to meet the demand. To meet the demand, we have to be continuously generate the power depending upon the demand. Okay, always we have to meet the demand. Once if he is not able to meet the demand, maybe if having a no rainfall, if hydropower plant is not able to utilize, then at that time what do we have to do? We have to increasing the power generation from the conventional, thermal or uranium thermal power plants. Okay, uranium, using the uranium power plants, we can increasing the power generation. Okay, if and in other case due to the summer season, we can use it wind and solar power. Okay, what are things is we are generating using that various sources that will be directly connected to the grid. Through that will be transmit, then that will be distribute depending upon the consumer requirement. We are meeting the demand. Okay, so unfortunately, some cases, if can't able to meet the demand, that's why we are setting down the power for the village areas, the small areas. We are setting down the power, then we can divert into the industries and where is needed. That cases, okay, if it's can't able to meet the demand, but unfortunately, that cases is not possible in our state. In our Tamil Nadu, we have sufficient energy at present we have. Okay, we have a sustainable system, so we are meeting the demand successfully. Okay, then and demand response controllable load, that means that is different. It's the load cases where we are using inside the industries. Okay, so varying the load, if is the productivity getting increased, then they are increasing the load, automatically they need more power. But once the industry are receiving the power from the substation, they can develop their own substation inside their industrial itself. Okay, they can stepping down, they can stepping up depending upon their requirement, then they can meet the demand what they are needed. Fine. Next thing is the structure of the power system. Okay, I told here generating station we are having. Okay, maybe you can think about whatever may be the generation, if a conventional power plant or non-conventional power plant, whatever maybe it is, then through the transformer, I told in the solar system we are getting the only the DC supply as a output, so we have to convert DC to AC. Okay, DC to AC using the inverters, then that again we can step up to the transformer, then we have to be connect to the grid, to the transmission system. So in the primary transmission system, I told what will be the power plant here, conventional power plant or non-conventional power plant, then we are stepping up through the transformer. Okay, this is a generating station, then this is a transformer, then is a 230 kV or more than that, we can be transmit, we can stepping up and transmit through the primary transmission system, and second using the primary and secondary transmission system, we can transmit it through the transmission lines. So see the towers. Okay, we are transmitting. So transmission for the consumer, see here 138 kV or 230 kV. Generally we are using the 230 kV transmission system. Okay, then it reaches the substation. Okay, I told the substation. From the substation, we are distributing using the transformer. They are stepping down. Then they can distribute depending upon the consumer's demand. Okay, as a primary consumers. Okay, see directly. Then they need a 16 kV. Then 20 depending upon the consumer's requirement. Like they can get 11 kV, 33 kV, or 3.3 kV. They can receive depending upon the primary consumers and commercial consumers. The substation will be divided and they will distribute using the distribution system. Okay, then here the 240 volt or 440 volt, whatever maybe it is, that will be given by the distribution transformers. This are called as a load. This side is called as a distribution system. This is called as a transmission system. This is a generating system. So this is a structure of from power generation to the starting into receiving end to the consumer. Okay, next we will see a single line diagram of our power system, SLD. Generally in the industry people they can say as a SLD, single line diagram of power system. Okay, so this is a generating station. It's 11 kV. So I told, switching the step up transformer, they can convert into 220 kV. It's a primary transmission system. Okay, then again they are stepping down into 130 kV or 66 kV or 33 kV. Okay, for some other receiving stations, that is called as a secondary transmission system. That is called as a secondary transmission system. While transmitting after a particular distance, if is another substation is there, they can stepping down and they will give to the nearby substation. Okay, that is called as a secondary transmission system. After that again they will be stepping down into 11 kV. Okay, from the secondary transmission system, then they can reach the substation. They can reach the substation. From the substation they can distribute using the distribution system. So primary distribution system and second distribution system up to the end consumers. Our objective is to meet the demand of the consumers. To meet the demand of the consumers, that is our objective. So depending upon the power requirement, we can calculate which is the peak hour, in what time the power requirement is mostly needed. Okay, depending upon that we have to be increasing the power generation or decreasing the power generation. Then we have to be transmit and we can distribute, and to we have to be successfully meet the demand. That's a structure of the power system. Okay, uh, thank you. So I hope if you understand how that power system is working. So the small review about the system. So it need a power generation, transmission and distribution up to the load. Okay, power generation using the power plants. That power plant need a energy sources. That energy sources we can getting from the nature. That may be a conventional energy sources or non-conventional energy sources. Depending upon the energy sources what we are using to generate the power, we are naming it conventional power plant or non-conventional power plant. After generation we can stepping up using the transformers, then we can transmit through the transmission system, then that will be reach the substation. From the substation we are distributing to the consumers. Okay, depending upon the type of the consumers, then we are satisfying the meeting of the demand. Fine, thank you for your listen. Thank you very much.